The CAT formula. So C stands for consumption, A stands for average depth of ascent, and T stands for time of ascent. Okay, so your dive depth is 30 meters. You have a 12-liter cylinder. What is your minimum gas for this dive? So we're using the CAT formula. So for C, our consumption, the average surface air consumption per minute is 20 liters per minute. So we're going to multiply 20 times 2, because 2 people are going to be sharing the gas, and we get 40 liters per minute. Next is our average depth of ascent. So we have 30 meters is our average, and we're going to be dividing that by 2, which gives us 15. And we're going to turn that into ATA, so atmospheres. So 15 meters is 2.5 ATA. Another way to find this that is useful, especially when you go on in scuba diving. So you're not always going to have the surface, because this equation is considering that the surface is your starting point always. But that won't always be the case if you go further into diving. Sometimes you just need to calculate how much gas you need to get to another air source at a different depth. So to do that, a good way to branch in to getting prepared for that future equation is to start by doing 30 meters, and then imagine you're starting at the surface. So we know 30 meters is equal to 4 ATA, and the surface has 1 atmospheric pressure. So we're going to add 4 and 1, which equals 5. 5 ATA. And then you're going to divide that by 2. So 5 divided by 2 equals 2.5 ATA. ATA. Let's see. Give me one moment here. So that's good. Okay. So to see that again, I'll actually give you an example of that going on later. We're just going to focus on the problem now. But I'll give you another example of that later so that you can understand that concept a little easier. So finally, we have our time, which is going to equal our maximum depth divided by our rate of ascent. So for this, we're making it super easy to understand, and we're just going to do an average rate of ascent of about 3 meters per minute. So we're dividing it by 3, which equals 10, and then we're going to add 1, which will be an extra minute in case to deal with emergencies. So that 1 is the extra minute we would have to share gas and to deal with any kind of emergency we'd have. So that would give us 11. So what we're going to do now is multiply 40 liters per minute times 2.5 ATA times 11. So let's see here. Let's go 40 times 2.5 times 11. And that would give us, let's see, 40 times 2.5 times 11. That will give us 1,100 liters. So you probably remember that we can't read liters on our SPG. So we're going to transform that 1,100 liters into bar. So I said earlier that we're using a 12-liter tank. So 1,100 liters divided by 12 equals 91.6. Whoops. Let's see, erase that. Equals 91.6. And we're going to be very conservative here. We can't read 91.6 on our SPG. So to be extra conservative, we're just going to round that up to 100 bar. So for this dive to 30 meters with an average surface consumption rate of 20 liters per minute and an ascent rate of 3 meters per minute, in case of emergency, we want to reserve 100 bar.